Hey guys, so we're finishing the 6.5 notes. So I'm in example 7 on page 8. So we want to solve the equation in the interval 0 to 2 pi. We have cotangent of x, cosine squared of x equals cotangent of x, right? So the first thing that I would do is try setting this equal to 0. Cotangent of x cosine squared x equals cotangent of x. So I could subtract cotangent of x from both sides. So we have cotangent of x cosine squared x minus cotangent of x equals 0. And notice on the left hand side I can factor out cotangent of x from both terms. So that would be cosine squared x minus 1 equals 0, right? So then, applying the zero factor theorem, that would give me that cotangent of x equals 0, or cosine squared x minus 1 equals 0, right? So if cotangent of x is 0, right, that means that tangent of x would be undefined. Right? So remember, tangent of x is undefined at pi over 2 and 3 pi over 2, right, if we're just stuck between 0 and 2 pi. And then for the cosine squared x minus 1 equals 0, I could add 1 to both sides and get cosine squared x equals 1. Take the square root of both sides, which leaves me with cosine of x equals plus or minus 1. Right? So cosine of x equals plus or minus 1 when x is 0 or when x is pi. Right? So if we think about plugging these into the original equation, remember, looking back on page 1, right, just a refresher, that cosine, because the functions we have here are cotangent and cosine in the original equation, right? We have cosine and cotangent. Cosine, the domain's all real numbers, so we don't have to worry there. But remember, cotangent is undefined at x equals n pi, right, where n is an integer. So we can't have we can't have any multiples of pi, right? So in other words, these guys are we need to throw those out, because if we plug those in to cotangent, that's going to give me an undefined result, right? So that's not going to be a solution to the equation. So these are extraneous. So we need to throw those out. So then the only contenders left is pi over 2 and 3 pi over 2, right? So pi over 2 and 3 pi over 2 will work. Right, so those are the two solutions for that. Right. So then objective 4, we want to be able to, potentially use some identities to solve trig equations, right? So if we look at example 8, we have cosecant squared minus 1 equals cotangent of x. And the way I'm looking at that is we have a Pythagorean identity that's cosecant squared x equals 1 plus cotangent squared x. So the way that I'm looking at this is if I replace cosecant squared x with this form, right, using the Pythagorean identity, if I substitute that in, then what I'll have left is cotangent squared. So it's better, in like these cases, if we can try to get it down to just be one trig function, and if one of them is squared and one of them is like to the first power, then that gets me into like a quadratic type of equation, right? So with a lot of these, it's just, kind of messing around and seeing what works and what doesn't work, right? So for this one, Pythagorean identity can help us out. So if I substitute that in, right, what I would have is 1 plus cotangent squared x, right, and just substitute that in, and then minus 1 equals cotangent of x. So notice the 1 minus 1 cancels out, so I'm left with cotangent squared x equals cotangent of x. And then I can subtract cotangent of x from both sides. And we get cotangent squared x minus cotangent of x equals 0. And then I could factor this, right? So I could pull a cotangent out of both terms, cotangent of x. So that leaves me with cotangent of x minus 1 equals 0. So then applying the zero factor theorem, that would mean that cotangent of x equals 0, or cotangent of x minus 1 equals 0. Right? So if I add 1 to both sides here, we get cotangent of x equals 1. Right? So far what I'm at is that cotangent of x equals 0 or cotangent of x equals 1. Right? So cotangent of x equals 0 gives me, right, this gives me that tangent of x is undefined. Right? I'm stuck in between 0 and 2 pi. So the values that tangent's undefined would be at pi over 2 and 3 pi over 2. Right? And then cotangent, right, that would give me tangent of x equals the reciprocal, but that would just give me 1 back. Right? So the values that tangent is equal to 1 are at the following, right? So this is going to deal with pi over 4, right? Because, so we already looked at this y previously. So if I have a right triangle, right, and these are both pi over 4, then this would be radical 2 over 2. This is radical 2 over 2, and this is 1, right? So if I take radical 2 divided by 2, then divide that by radical 2 divided by 2, that's what gives me 1, right? So in other words, we know that tangent of pi over 4 gives me 1, right? So that's my reference angle. So then if I start to think about, all students take calculus, here tangent's positive, so tangent's positive in the first quadrant and in the third quadrant, right? So these reference angles are both pi over 4. So this guy would be pi plus pi over 4, right? So this pi is 4 pi over 4, so that gives me 5 pi over 4, right? So the values, the solutions for x for this one would be 5 pi over 4 and pi over 4. All right, so then if we look at, my original functions, I have cosecant and cotangent. So if you look back at the original page, the first page, cotangent is undefined for multiples of pi, right? So notice none of my solutions are multiples of pi, so we don't have to worry about that for cotangent. And then cosecant is actually the same, right? Cosecant is also undefined for multiples of pi, right? So in other words, all of those check out. None of those are extra, right? So the solution set would be pi over 2, 3 pi over 2, 5 pi over 4, and pi over 4, right? And a good way to check these too is you can plug all of them into the original function and check them to see if they work, right? Just like you would plug things in and check with other algebraic equations, right? But all of those should check out. All right, so then example 9. So we have 2 minus 3 secant theta minus 2 secant squared theta equals 0, right? We want to find a solution between 0 and 360, right? So that's telling me, I want theta in degrees, right? So for this one, we're looking for solutions in degrees and not radians. So when I'm looking at this looks like a quadratic to me, right? I see secant squared, I see a secant, I see a plus some constant. So the first thing I would do is rearrange this and just write it how we're used to seeing quadratics. Write the square part first. So just use the commutative property of addition and rearrange the term. So we got negative 2 secant squared theta, and then I'd have minus 3 secant theta plus 2 equals 0. And then I like this first term to be positive, right? It makes it much nicer. So we could factor out that negative. So that would give me 2 secant squared theta plus 3 secant theta minus 2 equals 0. And then now I could actually multiply both sides by -1. And that just leaves me with 2 secant squared theta plus 3 secant theta minus 2 equals 0, right? So it just makes it a little cleaner, nicer to work with. And then I want to be able to factor this. So I could, say let u equals secant theta. So what that would give me is 2u squared plus 3u minus 2 equals 0. Right, so we can factor this. So you should be able to factor pretty well by now. This is, this will factor in to be 2u minus 1 times u plus 2 equals 0. Right, and you can factor that by grouping using the AC method like we did before. If you're not sure of how to factor that, feel free to look at my my completed notes I upload to Canvas to see how to do that. Right, so now we can apply the zero factor theorem. So 2u minus 1 is going to equal 0, or u plus 2 equals 0. So I need to solve both of those for u. So add 1 to both sides here. We get 2u equals 1. Then divide both sides by 2. And that gives me u equals 1/2. Here I would subtract 2 from both sides, and I get u equals -2. Right? So, so what that leaves me with, just plugging secant theta back in for u, that would leave me with secant theta equals -2, or secant theta equals 1/2, right? So secant theta equals -2 is the same thing as cosine of theta equals -1/2, right? It's reciprocal. So then this would give me cosine of theta equals 2, right? But again, cosine of theta is always going to be in between -1 and 1, so this guy gets thrown out, right? So cosine of theta equals -1/2, right? So the triangle, the special triangle that deals with the half, right? It's a 30, 60, 90 triangle, right? So 30, 60 degrees. So across from 30 we got 1, square root of 3 and 2. And if we wanted to, we could divide everything by 2, which makes that 1, right, if you prefer that. So we're considering cosine, so that's the adjacent angle. So the adjacent angle to 1/2 is 60 degrees. Right, so that's going to be my reference angle. And then we want cosine to be negative. So cosine is negative, right? All students take calculus. Cosine is going to be negative in the second and the third quadrant. So those reference angles are 60 degrees. Right? So that leaves me with, theta being 180 degrees minus 60 degrees, which gives me 120 degrees. Or theta is going to be 180 degrees plus 60 degrees, which is 240 degrees. Right, and both of those check out, right? And secant is defined at those two values, right? So, so my solution set is 120 degrees and 240 degrees. Right. All right. All right. So example 10. So we're going to be able to solve the equation at interval 0 to 2 pi. So I have tangent of x plus 1 and secant of x, right? So, an identity that deals with tangent and secant, right, is tangent squared x plus 1 equals secant squared x. right? So notice that this is just tangent, not tangent squared. This is just secant, not secant squared. So a tactic here is to take the equation tangent of x plus 1 equals secant of x, and then we're going to actually square both sides of the equation, right? So here, right, this would be tangent of x plus 1 times tangent of x plus 1 equals secant squared x. So foiling the left-hand side, that would give me tangent squared x, plus tangent of x plus tangent of x plus 1 equals secant squared x. So the left-hand side would be tangent squared x plus 2 tangent of x plus 1 equals secant squared x. Right? So then what I can do is plug in tangent squared x plus 1, plug that in for secant squared x, and so I get tangent squared x plus 2 tangent of x plus 1 equals, and this would be tangent squared x plus 1. Then I could subtract tangent squared x and subtract 1 from both sides. So what that leaves me with, so that cancels, these cancel, so we're just left with 2 tangent of x equals 0, right? And if I divide both sides by 2, this gives me that tangent of x equals 0, right? So I'm just going to come off to the side here and finish this problem, right? So what we conclude with so far is that tangent of x equals 0, right? So the possibilities are x would be equal to 0 or pi in order for that to happen, right? Because we're stuck in between 0 and 2 pi, right? Remember, x is in between 0 and 2 pi, right? So those are the two values. That gives me a tangent of 0, right? But something that's important to note here, so when we square both sides of this equation, we're actually possibly introducing additional solutions. So I mentioned before, and you definitely want to do it here, is it's helpful to plug in values into both of these and see if it works out, right? So if I plug in x equals 0 into the original equation, which is tangent of x plus 1 equals secant of x, so we'd have tangent of 0 plus 1 equals secant of 0. So tangent of 0 is 0, so I have 0 plus 1 equals, and then secant of 0 is 1, so we get 1 equals 1, so that's good, right? So so far my solution set, 0's in there, right? And then if I test x equals pi, right, that would give me tangent of pi plus 1 equals secant of pi. Tangent of pi, like we said, is 0, right? We'd have 0 plus 1 equals, and then secant of pi is -1, right? So we'd have 1 equals -1, which is not equal, right? So therefore, x equals pi is extraneous, right? So we need to throw that out. So the only possible solution here is x equals 0, right? All right, so this next objective is we want to be able to use inverse functions to express solutions to trig equations. So example 11, we want to solve the equation with intervals 0 to 2 pi, give exact solutions in radians, and give approximations in degrees rounded to 1 decimal place, right? So if I want to solve cosine of x equals 0.6, that doesn't come out to a nice whole, a nice number using our special right triangles, right? But what this implies, right, is that cosine of -1, the inverse, so arc cosine of 0.6 is equal to x, right? That's what that implies. And here, this tells me a cosine is positive, right? So if I draw my XY grid, right? All students take calculus. So cosine is going to be positive in the first quadrant and also in the fourth quadrant, right? So x is this reference angle, right? So x is this angle and x is this reference angle, right? So my exact solutions are going to be the set of cosine, inverse cosine of 0.6, and then this angle is going to be 2 pi minus inverse cosine of 0.6. Right, so the only way to write this exactly is to leave it using the inverse cosine, the inverse trig function. Right, so then we're asked to approximate this in degrees. Right, so if we pull out, let me grab my calculator. Right, so we want to make sure our mode is in degrees here. And then we want to do second cosine, right? Arc cosine of 0.6. And we're getting 53.13, right? So that's x, right? So remember the other one was 2 pi minus that, right? So that would be 360 degrees, right? So if I take 360 minus this answer, that'll give me, So hang on, let me put 360 in here. 360 minus that. Then we get the 306.9 roughly, right? So those are going to be my two values, approximations, and degrees. So 53.1 degrees and 306.9 degrees, right? So then the next one, we have tangent of x equals -5, right? This is going to imply that the inverse tan of -5 equals x. So tangent's negative, right? So if I draw my grid, tangent's going to be negative in the second quadrant and the fourth quadrant, right? So this reference angle is x and this reference angle is x, which is equal to inverse tan of -5. So how do we find those, right? So my exact solutions, right, would be, I think we want them in radians, right, for the exact. So that would be pi minus inverse tan of -5. That's to get this one in the second quadrant. And then to get the one in the fourth quadrant, we would take 2 pi minus inverse tan of -5. Right? So then to be able to get the approximate in degrees, right? First we want to figure out what x is, the reference angle, right? So we have this picture. So I want to find what this is. So if I use my calculator and do second tangent of -5, we get -78.69, right? So the reference angle is going to be 78.69 degrees, right? Right, so if I take 360 minus 78.69, I get 281.31, and that's going to be that angle in the fourth quadrant. So to get the angle in the second quadrant, I would want to take 180 minus the 78.69. We get 101.31, right? So those are going to be those two values. So this would be 78 was it 69, I believe? Yes. Right. So that means this was 78.69. So I was just, using some basic, math measurement to figure that out. So we get roughly 101.31 degrees and 281 point, I think it was 31 degrees. Right. Yep. All right. So then objective 6 is approximating solutions of trig equations on a calculator. So these methods are used for equations that are really hard to solve algebraically, that we can use graphing methods to solve those, right? But for time's sake, I'm actually going to throw this objective out. It's not required for this course, set by the Columbus campus. So I'm just going to throw that part out. And instead, I want to do one where you have to use the quadratic equation, because I want to make sure you know how to do that okay, right? So I'm just going to come down here and say example number 12, and this will be the last example that we do, right? So this is similar to number 11 in the homework, right, in the mulch. So it says to use the non-graphing part of your calculator to solve the equation cosine of 2x plus 3.8 cosine of x equals 1.8 for x within the interval pi to 2 pi. Right? And then we're told to round to 4 decimal places. Right? So there's the problem. Right? So first thing I would do, the first thing that will come in handy here is notice that we have cosine of 2x and then cosine of x, right? So it'd be really nice if I could just have cosine of x. So if we look at, maybe there's a double angle formula that we could use as substitute for this, and there is, right? So the double angle formula, if you remember, is cosine of 2x equals 2 cosine squared x minus 1. So if I substitute this part in to this part of the equation, that would be awesome, right? Because then I have just cosine of x, plain old x, but it's squared, and then I have a cosine of x, so I get it in like a quadratic form. So plugging that in, we would have 2 cosine squared x minus 1 plus 3.8 cosine of x equals 1.8, right? And then if I subtract 1.8 from both sides, what we end up getting is 2 cosine squared x plus, I'm going to write the cosine of x term next, and then this would be minus 2.8 equals 0. Right? And you can try to factor this, but this, that's not going to factor. You can try it, but it won't work. So what we need to do is use the quadratic equation. Right? So the quadratic equation, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Right? That's the quadratic equation for solving for x. Right? So the difference here, though, is that x is not actually the thing that's being squared. Right? Really, what we're solving for when we do this trig equation is we're solving for cosine of x. The roots of that are negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So instead of x, x equals actually cosine of x, because that's what's being squared, right? That's cosine squared of x, that's cosine of x. So we're finding possible roots for cosine of x, and then we're going to have to, and then after we find some answers there, then we're going to want to find, find the solution for x, right? So this is, like in algebra, but in trig, the quadratic equation works a little differently, right? So this would be equal to, so my b value is 3.8, so we'd have negative 3.8 plus minus the square root of, so that would be 3.8 squared, right? Because this is b. Let me write this. So b equals is 3.8, a equals 2, and c equals negative 2.8. Right, those are the coefficients. So we have 3.8 squared minus 4 times a, which is 2, times c, which is negative 2.8, all divided by 2a. So a was 2 times 2. So this gives me, so if you simplify the radicand, you get 36.84. So this would be negative 3.8 plus minus the square root of 36.84, all divided by 4, right? So that means that cosine of x is equal to negative 3.8 plus the square root of 36.84 divided by 4, or cosine of x equals negative 3.8 minus the square root of 36.84 all divided by 4, right? So I think here it's important to kind of get an approximation. So if you plug this in your calculator, this is approximately 0.5674, right? This guy is approximately negative 2.467, right? So what this tells me, this is a red flag, right? Because cosine of x should always be in between negative 1 and 1. So in other words, this guy gets thrown out, right? We can't have that. So my attention draws to this part of the equation, right? So in order to solve for x, right, x would be equal to inverse cosine of this guy, right, which is negative 3.8 plus the square root of 36.84 all divided by 4, right? So we can grab your calculator, and we want our answer in radians, so I need to change the mode, make sure my mode's in radians. Right, so we want inverse cosine of, I'm going to put this in parentheses, negative 3.8 plus the square root of 36.84, and then divided by 4. Right, so we get 0.96745 roughly, right? So x is approximately equal to 0.9674525, and so forth. So important thing to note here, though, is that my answer, we said, was restricted between pi and 2 pi, right? So we have to be somewhere over here, right? So cosine is positive, so all students take calculus. So that tells me I got to be in the 4th quadrant, right? Because only the 3rd and 4th quadrant are an option because of because of the constraint in the beginning, this constraint. So we got to be in here. So this is going to be my reference angle, right? So this is the 0.9674525, right? So my solution for x is actually going to end up being 2 pi minus this value here, right? So maybe I should call this x prime, right? Because that's my reference angle, not necessarily what the x value is, right? So this would be 2 pi minus inverse cosine of the negative 3.8 plus the square root of 36.84 all divided by 4, right? This would be the exact answer. So the approximate answer would be to take 2 pi minus this 0.9674525 number, and this turns out to be 5.3157, right? Because we were asked to round that to 4 decimal spots, right? So in other words, if you go back to your calculator, we would want to take 2 pi minus my answer, second answer, and we get that answer, right? All right. So hopefully that's helpful. I know this section is pretty large and has a lot of work to it. So if you have questions, feel free reach out to me, let me know, and I'll be glad to help. All right. Thanks.